Hi everyone, this is a short little lesson here about how to do an ordinary annuity calculation. So we have a situation, a question where we have an initial investment of $5,000. So this is deposited into a savings plan or an investment annuity. The interest rate is stated to be 8.6% per annum, but it's compounding monthly. So first convert to a decimal and then divide by 12. Now let's do that on our calculator here. So 0.086 divided by 12, and we can see the number here runs on a long way. So with something like this, it would be best to store that in memory. So I have the recall and the store buttons here. I press store, and then you can see in green little A, B, C, D, E. I'll store that in A, and I have to hit enter to get that. If I just clear, you'll think, oh, I've lost it, but I can always press recall A. There's the number. And if I wanted to perform a calculation, as I will in a minute, I'd use the alpha key. So that number was, let me just see again, recall A, there it is. Now, I'll just write down on my page here, I won't try to write everything, it was 00716. Now, I'm making a little note here that I'm storing that in memory A. So that's fine. Don't forget we have to calculate the value of R. R is defined as 1 plus I. So we can see that if we add 1 to this number, it'll be 1.00716. And because that's an important number to use in my calculations, so I'll just clear that. I'll go 1 plus, now this is where I have to use the alpha key and then press A, so that I've got the A as a pronumeral in my calculation. There's the answer that now that's the one I really need to store. So I will store that, and this time I'll store it in memory B. And that's now going to be sitting there ready for me in the future, and I'll make a little note in my working here, just for myself, that that one's stored in memory B, just so I don't forget. Now, this person, apart from their $5,000 initial deposit, they also make smaller deposits of $450 per month. And the term of this investment, so this is a savings plan, an investment annuity, they're saving for 4 years. Now, of course, as they're adding interest monthly and they're adding an extra deposit monthly, we need to calculate the number of months. So we have 48 months. Now, I'm not going to bother storing 450 and 48 because those numbers are so easy to type that there's no possibility of rounding off errors going on there. Now for the calculation. The formula that we need to find for this is the amount that the investment annuity grows to after 48 rests or 48 monthly installments is A0 R to the power of N. Now you'll remember that that's really just a compound interest formula based on my initial 5,000 deposit sitting there attracting compounding interest for the 48 periods. But I also have to worry about these extra deposits. So D is the extra deposit, and our formula goes R to the power of N minus 1 over R minus 1. Now let's write some numbers down. We had 5,000, 1.007, and there were more digits, but the calculator will remember those for me, to the power 48. My deposit amount per month is 450. R again is 1.007 with all those extra digits, to the power 48 minus 1, all divided by 1.007 minus 1. Now, if I typed that on the calculator exactly how I've just written it there, I will get an awfully inaccurate answer because I've rounded off my value of R to 1.007. Those extra decimal points will make an actually a very large difference, especially the ones here with the power of 48. They will make a big difference to my calculation. And that's why I need to use the calculator to recall them. So hope you can see that there. So let's just clear what's on the display. Now I'm not going to attempt to do all of this in one go. I'm going to first enter this bit here. So let's try 5,000 multiplied by. Now remember that this value was stored in memory B. So I have to go alpha B. Then this key means power of, and my power is 48. That gives me $7,044.25. I might store that one for future reference in C. There we go. So I'll just put that to one side as I write down on my page the next part. I had $7,044.25. And I stored that in memory C. So I'll just write that there underneath so I remember what that's about. Now, let's do the second part of this calculation. Just get my calculator back. There it is. I think I stored that one, didn't I? I hope I did. Let's soon find out. Let's go recall C. Yes, there it is. Happy days. Now, let's do this bit. We need to do a numerator and then a denominator. There's a lot to this. I might start with the brackets in the numerator here, 1.007 to the power 48. That was the value stored in B to the power of 48. Let's just hit equals. So that first bit comes to 1.4 something something. Now I subtract 1. So that's just the bit in the brackets on the numerator. Then I multiply by 450. Let's hit equals. That's now the numerator, the entire numerator. Now I'll divide by, and I better use my brackets. This number was stored in B, so I'll need to go alpha B, subtract 1, and close out those brackets. So the B minus 1 is the denominator. That gives me, for the entire second part of this calculation, $25,671.93. I'm going to store that in D. There we are. So I'll just pop that over to the side and I'll write that down. It was $25,000, 671 and 93 cents. And just I stored that in D. Now, all I really need to do is go on the calculator C plus D. So let's just clear that up, and we'll go alpha C plus alpha D. There's my answer, 32,716 and 17 cents. So let's write that down as our final answer. The answer is $32,716.17. And that's how much our friend would have had in their investment annuity account after 4 years. An initial deposit of $5,000. There's the initial deposit of $5,000. Remember, this part of the formula is just like the compound interest formula. That 5,000 sits there for 4 years attracting compound interest. They then made monthly deposits of $450, and those monthly deposits each attracted interest. Now, of course, the first one, it attracted 48 months worth of interest. The next one only would have been sitting there for 47 months, and so forth. So that is the formula for an annuity where you're doing monthly deposits. And these investment annuities, often, like this case, you have an initial deposit and then the extra monthly contributions. This one lasted for 4 years and totaled $32,716. Now, this is beyond the question, but just as a matter of interest, it's fun sometimes to work out Well, exactly how much of that $32,000 was contributed by our investor? So there were 48 payments of $450 that were deposited. So this number here, 25,671, well, 21,600 of that was actually the money deposited. But of course, the additional money that's appeared here is due to the interest that's been attracted. Now, we could also add to that the original $5,000 investment, and we see that altogether our friend here has contributed or deposited $26,600. In the long run, though, the investment has grown considerably more than this, and that's due to the interest that's been attracted. Some of that interest came from the initial deposit, some came from the monthly contributions. But altogether, now let's go, I'll just have to, oh no, I won't remember, I'll store, won't I? Let's store that. Now, I can store it in memory A. I've finished with the other stuff, so I don't really care that I've written on top of what was in memory A. Let's go $32,716.17, and let's subtract that number that we stored. That's how much total interest was added. So our friend earned $6,116.17 interest across that 4 years, and they invested, or they saved, $26,600. So that's how investment annuities work. That's all for now. Thanks for watching.